Now it might be that you've watched one of my other videos about type inference. So type annotations and type inference are kind of the same thing, but regardless of the fact, we're going to still talk about what type annotations are. So let's start off with defining a constant and saying name, and then we're going to say var is equal to age is equal to 45. Now, as we know here that name cannot be changed, although you can technically change your name. Let's just say in this universe that once you've been given a name, you're not allowed to change it. But your age, obviously, it goes up every 365 days, approximately. And so we're going to need to be able to change the value of this one, age. But what if in the future, in the code, someone's a bit unsure about what name is, and what age is, and what type it has? Everyone could misunderstand it. So how, when you look at that variable, how can you understand what type it actually has, apart from using the question mark and seeing here that the let name is actually equal to string, or var age is equal to an integer, right? How can you tell the people to do this? Well, it's really super simple. Type annotation always comes after the variable identifier, or let's just call it the variable identifier. And here we then define what type the value of this one variable has, and it is then David. So we're not talking about whether it's immutable or immutable, because that is this here. So it's just saying, hey, what value does this one variable have? Let or var is when I say variable. When I say variable, I mean it's either immutable or mutable, immutable or immutable, okay? And so in this sense, we now know that name is equal to a string, and var age is equal to an int. Okay, so this is basically how you can do this. It's type annotations are type inference, kind of, but if you don't use type annotations, then the compiler will infer what the type is supposed to be based upon the right hand side. However, if you annotate it, you definitely cannot say 45 here, all right? Because your type annotation is different now to the type inference that is occurred. So the value that you are initializing this one variable with is an integer, and as you can see here, it cannot convert value of int to specified type string. So your value of initialization has to match that of your type annotation. Okay, now like I said, if we don't provide a type annotation, the compiler will infer that name now is an integer. It doesn't care what name there, the character, the string that you've put for that variable identifier. It will just infer it. Now in future, probably in 10 years, when you have AI, it'll probably change the name. It'll probably go, wait a minute, name is equal to a string, and so on. But right now, all we're saying is that the text inside that string doesn't matter, right? It's going to be the value that the compiler can infer it to be. So this is what you need to understand, right? Is that we are saying here that name is equal to David, and the type annotation is a string, and the compiler has also inferred that this one value is actually a string, and that does match the type annotation too. So if we then wanted to make points on a map or something, and we would then say 10, x is 10, and y is equal to 20, then we can see here that x and y are being declared on a single line, right? So we're doing multiple declarations on a single line, and we can see that x has been inferred to be an integer, and y has been inferred to be an integer too. Now, we could quite easily say that y is going to be 20.0. So now when we do question mark on this, we see var x is equal to an int, and we do it on y as well. We can see var y is equal to double, because the type annotation has said it's a double. We're just saying that all of these declarations and initializations are all variables, okay? It doesn't matter that they're different types, right? We could say here that this is an int here, and that would work perfectly fine as well. So the type annotation and also then the variable type, whether it's let or var, they're not related to each other, all right? It just the comma is just basically saying everything after this should have the same var or let added to it. All right. So this is basically type annotation. It's just like the flip side of type inference, and that's all you really need to understand. Now, in my personal subjective opinion, you should always take the time out to, one, either give every single variable, be it immutable or mutable, always a type annotation, always, 100% of the time. Now, if you are going to allow for some variables to not use it, then you need to make sure that every single variable has been named correctly. Okay, so that even a human, when they're looking at the variable name throughout your code, can infer through our own brain what type and what it does. Okay, so this is just a top tip for you. If you've got a company and you've got some rulings for your code and for all of your developers, some guidelines, some standards that you're going to go by, is that if you are either going to say we want to use 100% type annotations, then you can be a little bit more relaxed on the variable names, although you shouldn't be, because at least you can see what type that should be at that one time. Now, with Swift has a very good compiler, so you can kind of it removes a lot of bugs just because of the compiler, is what I'm trying to say. With that said, I hope that you've got something out of this one video. Thanks very much for watching. Don't forget to like, subscribe, and write any feedbacks that you have in the comment section down below. And I'll see you in the next video. Ciao, ciao, and goodbye.